I wanted to review a couple of different types of problems to help you guys better prepare for the midterm exam. One of those types of problems is how we can apply quadratic equations to help us to solve problems. So we're going to take a look at this problem here. So 600 feet of fencing is to be used to enclose 3 sides of a rectangular area. We want to find the dimensions of the rectangle that would enclose the largest area with this much fencing. So the first thing that I'd want to do with any type of problem like this is figure out what does it look like so that I can better imagine this. So I've got one side of this enclosure that's already a natural boundary, but then I need to enclose 3 other sides of this enclosure based on what we know. And I'm going to label these sides as X and X on the left and right, and then I'm going to call this bottom side Y. Now, if I were to take those 3 sides and add them together, so if I take the first X and add the second X, and then add the Y, I could say that's equal to 600. Now, I don't necessarily want X and Y both on the same side. In fact, I'd probably want to figure out what Y is equal to in terms of X, so that I can build equations just with Y's in them. So I'm going to take these 2 x's over to the right side, rearrange that, and make y equal to 600 minus 2x. That way, I know this here, this bottom side, is 600 minus 2x. Now, the reason that's important is because we want to talk about the area, and when we talk about area, we don't necessarily want 2 different variables when we're writing that area equation. So we know the area of a rectangle in general terms is length times the width, or base times height. So I'm going to take that area and set it equal to our base times our height. So our base and height are x and 600 minus 2x. And when I multiply that out, I end up getting this equation of 600x minus 2x squared. Now, the reason that's nice is because at this point we have a quadratic, and we know visually what a quadratic would look like. In this case, with it being a negative 2x squared, I know visually I've got this quadratic that looks something like this. Vertex we can figure out, intercepts we can figure out, just depends on what we're trying to find. Now here it says we want to find the dimensions of the rectangle that would enclose the largest area. Well, if I'm looking at that quadratic, that largest area is going to happen right up here at the vertex. So the way we're going to find the vertex is by taking negative b over 2a. So negative b over 2a, in this case, my b value is 600, so I can say negative 600 divided by 2 times a, and our a value is negative 2. So then if I divide those out, I end up getting a positive value because the 2 negatives cancel out. 600 divided by 2 is 300, divided by another 2 is 150. So what does that represent? Well, in our equation up here, we had an x value for our variable. So this should equal our x. Okay, so that's our x value right there. Well, and it was just asking for dimensions, so there's one of our dimensions right there. 150 is one of the dimensions. How do I get the other one? Well, the other one, we had this equation over here for y. So if I take that 150 and plug it in, I can get my y value. So my y value is going to equal 600 minus 2 times that 150 that I just found. And that should give me my y. So 600 minus 300 ends up giving me 300. And each of these is feet. So I'm going to make sure to label that as feet. Come back over here and label that as feet as well. So my two dimensions are 150 feet and 300 feet to create the largest area. And then if it wanted us to find the actual area, we could either take that 150 that we found for x and plug it back into our area equation, or we could just take those two dimensions that we found, the 150 and the 300, multiply them together, and we would have our maximum area.